Okay, hi, my name is Michael Gutensohn. I'm a co-PI in the project here. My research interest is on the scent of flowers. So everyone knows that flowers smell and we all like to sniff them. But of course that's one of the really important things that drives bees and pollinators in general to flowers. The scent is normally made up of a blend of different compounds. And so within this project we're interested in how climate change, how temperature changes influences the production and the emission of these compounds from the flowers. And so our expectation is that temperature changes can change the overall amount, so how scented or not scented a flower is. But on top of this, it could be that individual compounds that are important for the bees to detect the flowers are affected differently by the temperature, so that means the relative amounts of each component is changing, and that changes the overall blend, and by that might irritate or disturb the bees and might inhibit them or hinder them of finding flowers. So that's what we're particularly interested in looking at. And then at the same time we're also looking a little bit at the rewards of those the flowers, so the nectar and the pollen. That's basically what the bees are feeding on. And again, this is made by the plant, it's biochemical processes, and it's well known that these processes are affected by temperature changes, even by very little. Just a degree or two can make a huge difference. Again, in the amounts, for example, in the nectar it's sugar, so the sugar content could increase or decrease. And then also again in the composition, there's some of these scent compounds are also found in the nectar, and that of course could affect the health of the bees. These are trivially said essential oils, and essential oils are also used by humans for treating diseases, and so we're suspecting that also could have a profound effect on the health and well-being of the bees as well. Yeah, I mean, knowing how climate change, so temperature changes, would affect these processes, and in particular affects different varieties that we're testing of, like the blueberries, or in future also the blackberries. So the outcome would be hopefully finding accessions or varieties that are better suited for changed temperatures or conditions, and would still work in the attraction, highly efficiently work in the attraction of the bees. I mean, that's the big issue. If the bees are not coming anymore, we have less yield, and we would also affect the quality of the produce basically. So if we find varieties that are better suited at these other temperatures, hopefully we can compensate some of this.